So far the table has had a fixed size. Now let's see what happens when it fills up and how the table grows itself. We call this rehashing. When alpha, which is n over m, climbs past the threshold, the table doubles its bucket count and reinserts every key. Look at the old table. It has 4 buckets and 4 items, so alpha is 4 over 4, which is 1.0. That is over the 0.75 threshold, so it is time to grow to 8 buckets. We reinsert each key with hash of the key, mod the new size, which is 8. Banana was at slot 0 in the old table. In the 8 bucket table it hashes to slot 4, so banana moves. Apple was at slot 1. Now it hashes to slot 5. Apple moves 2. Cherry was at slot 2, and in the bigger table it still hashes to slot 2, so cherry happens to stay put. Date was at slot 3, and it also lands on slot 3 again. The table doubled from 4 to 8. Alpha dropped from 1.0 to 0.5, and every key was reinserted. 2 of the 4 keys changed index. Here is the rehash in C for the chaining version. It takes the table and the new, larger bucket count. First, we allocate a fresh bucket array with calloc, sized for the new count. Calloc also zeroes it, so every new bucket starts empty. Then we walk every old bucket, one by one. For each bucket, we follow its chain node by node. For each node, we first save p arrow next into a local called next. We do this before we relink, because the relink is about to overwrite that field, and we would lose the rest of the chain. Then we compute the node's new bucket, hashing its key against the new size. This is why indices change on a rehash. We splice the node into the front of its new bucket. Its next points at the current head, and the bucket now points at the node. The same node is replaced, not reallocated. When every node has moved, we free only the old bucket array and point the table at the new one with its new size. The nodes themselves were never freed. There is no pseudocode for the rehash, deliberately. Rethreading existing nodes is plumbing over Chapter 4, not a new algorithm. And the cost argument is one you have already seen. It is the same amortized argument as Chapter 3's array doubling. A rare big O of n rehash keeps insert big O of 1 on average. Same shape, new structure.